All right, number one, what is the domain and range of the function defined by absolute value of x plus 3 minus 2, both in set builder and in interval notation, and then we're also finding the x and y intercepts. So the first thing we want to do is we want to look at the graph of, there we go, y equals absolute value of, let's see, what was it, x plus 3, and then minus 2, yes. Okay, so we can see here that the domain is definitely all round numbers because it uses all of the x's, and the range is everything from -2 up. So let's say that properly. First of all, in set notation. In set notation, the domain is just all real numbers, and the range is the set of y, so that y is greater than or equal to -2. In interval notation, the domain would be -infinity to +infinity. Again, that means all real numbers. Or square bracket -2 and infinity, for the range in interval notation. So again, this one is set notation, and this one is interval notation. You need to know both of them. Okay, so the x and y intercepts, let's go back to the graph. We can see here the x intercepts are at, what, -1 and 5, and the y-intercept is at +1. So we're just going to state those two numbers. So the x-intercept is at, what was it again? -5 and -1, there we go. -5 and 0. And -1 and 0, and the y-intercept was 0 and 1. Okay, so for number 2, writing the transformation of vertical compression by a factor of 1/4, that would be not f of x, that's a y. Y equals, and since it's a compression, we're just multiplying, so it's literally just 1/4 times x. For number 3, the transformations to the graph, so this was our parent function. It's asking how is this function being changed. So we see the +5 inside of the parentheses. That means the graph is moving to the left 5. And the -9 outside of the grouping symbols means that it's moving down 9. Okay, number 4, the piecewise function. So I do need a graph, like graph paper for this one, so I'm going to come down here. And I'm going to be doing this one in pieces. So before I actually do the graph, I'm going to do the different colors here. So like, let's just start with the first one. So the first one, if you're looking at your study guide, is just 6. Like there's no x or y or no x in it. So it's a constant function. And it says from -8 to 1. So we want to use -8, we want to use 1, and then just any number in between, I'm going to use 0. And since it's a constant, that just means it's just going to be 6. So that's going to be my first part of my graph. The second part of my graph, so that's the one that's -2x, is restricting the domain of this one to everything between +1 and 8. And I'm just going to pick a number in between. I'm going to use 4. And that was -2x. So 1 times -2, 4 times -2, and 8 times -2. Remember, you do have to use the first and the last number. The middle number is kind of optional since these are all linear. All right, and then the last part of the function, -2 plus x. Again, the domain for that one's restricted between 8 and 16. Just pick a number in between. I'm going to use 12. So -2 plus 8 would be 6, -2 plus 12 would be 10, and -2 plus 16 would be 14. Again, I'm just using those functions for those separately there on number 4. Okay, so this is going to be a really large graph. So it looks like my smallest x is -8, and my largest x is 16. So I need a pretty long graph this way. Please excuse my not, oh wait, well you can't see it very well. And then it looks like here my smallest x on my, y is -16, and my largest y is positive 14. So again, I'm going to need a pretty tall graph. So I'm going to have to shift my graph a little. That's okay. We'll compromise. You'll be using an entire piece of graph paper for this one on the test, so you'll have plenty of room. Okay, so let's graph it, and maybe we won't have to tweak it any. Okay, so let's do each one of the individual pieces going back here. So this first one, -8, 1, 2, 3, 4, 5, 6, 7, 8 is actually here. 1, 2, 3, 4, 5, 6. 0 and 6, and 1 and 6. Again, that's a constant function because there weren't any x's in it as constant. Now, I actually just made a mistake. If you'll look at the domain there on number 4, it says -8 is less than or equal to x, so this definitely needs to be a closed circle. The point in between is also a point that's included, but here was my mistake. My mistake was this one right here should not be an open circle because it's just less than 1, so that is an open circle right there. So this part of the function, there we go. So that's the first part. All right, the second part of the function was 1 and -2. Now again, it's less than or equal to 1, so 1 and -2 is going to be a closed circle. 4 and -8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Again, the ones in between are always closed. And then the 8 is going to be an open circle because it's just less than 8. So let me scoot my graph a little bit. 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 13, 14, 15, 16, all the way down here. That one's going to be an open circle. And then I'm just going to connect these. There we go. So that's the second part of my piecewise function. And then the last part of my piecewise function is going to actually come back up here. So this was 8 here, and then up 6. Now, if you look at this one, both of these are equal to's. It's 8 is less than or equal to x is less than or equal to 16. So all of these are going to be closed circles. 9, 10, 11, 12, and 10, 2, 3, 6, 7, 8, 9, 10, and then 16 and 14. This is the one I'm worried about fitting. 12, 13, 14, 15, 16. That's 10, 11, 12, 13. Oh, wow, I just fit. Wow. Okay, and again, that's a closed circle. So go me. All right, so that's it. That was the piecewise function for number 4. It's in literal pieces. Make your table, and then make sure you're using the open and closed circles appropriately. All right, then let's look at number 5. Number 5 is this: describe where the open closed points were on the floor function. Remember, that was one of the step functions we looked at. On the floor function, we have the closed point is on the left, and the open point was on the right. You can go back and look at your notes for that one, because if you remember, the ceiling was exactly the opposite. The domain and the range of the greatest integer function. The domain was all real numbers, so I'm just going to write it in set notation for this one because it's going to be easiest, because the range, if you remember, we said it was the set of all integers. And that's because the graph is literal steps at the integers. All right, evaluating these functions. Number 7, so whenever it's a square on both the top and the bottom, like it's a square bracket, that is the greatest integer function. And so that always, regardless of the decimal, goes up. That's 2. Not 2. Wow, sorry. I'm having a moment. It goes up. I said it. It goes 3. Sorry. The floor for number 8, so you can see the little, it's a floor function here. So it's going to go down regardless. Remember, don't think of this as rounding. It either goes up or down, depending if it's a ceiling or a floor. So the floor goes down, so that one is going to be 8. And then number 9 is a ceiling, again, because here you can see the brackets on the top. So that's going to go up to the next number, which is 7. And that is your review.